All right, happy Monday morning. Quick reprise from Friday. We've got compound interest. And the formula that we've got for compound interest was the simple f equals p multiplied by 1 plus r over n raised to the nt, where f is our final amount or full amount, that's the principal and the interest. P is our principal, that's our initial amount. We've got r as our interest rate, always as a decimal. N is the number of annual compounds per year. That's the same n because that's the same letter. T is time, always in years. So from Friday, we solve for P, we solve for F. Basically, plug it in, you get F. Plug everything in, divide, you get P. Okay, good? Good. Today, going to the other two variables for which we can solve. So, finding the interest rate. Say we have, now this goes with example number 4 off of the notes sheet that is on Google Classroom from Friday. Just carry on with that. $2,500 is invested, so we've got a principal of $2,500. Compounded quarterly, that tells us the n value is 4. Find your interest rate, so cues me in. I need to solve for the interest rate because it says solve for the interest rate. We've got a value of $3,000. There's our F of $3,000 after 15 months. So we've got time is 15 months, but remember time that needs to be in years, so that is 1.25 years, or I could just do 15 over 12. That's 1.25. All right, so we've got everything in. We'll plug it into the formula F equals P, 1 plus R over N raised to the NT. Well, we've got $3,000 equals 2,500. 1 plus R, we don't know R, over 4 raised to the 4 times 1.25. So 4 times 1.25. Got multiplication here, so I will divide. We've got 3,000 divided by 2,500 equals, in parentheses, 1 plus r over 4 raised to the, well, that's going to be 5. 4 times 1.25 gets us 5. We see the variable is inside the parentheses, so we need to work for the outside. Get rid of that 5. I'm going to take the 5th root of both sides. So I've got 3,000 divided by 2,500 raised to the 1/5 power. 5th exponent, 1/5. That is the 5th root. That will eliminate that. We've got on the right side 1 plus r over 4. Subtract 1. 3,000 over 2,500 raised to the 1/5 minus 1 equals r over 4. Multiply by the 4, the whole thing. Now this you can plug all in the calculator. My calculator is over there. I'll do that all at the end. Solve for r. We've got r equals 4 multiplied by the whole thing. 3,000 over 2,500 raised to the 1/5 power minus 1. We get r. Now it's time. All right, so we've got 4 multiplied by, be careful with your parentheses. Notice my calculator puts it in there, 1 over 5 in the exponent. If your calculator does not do that, you need to be careful with parentheses. Exit out, minus 1, close parentheses. There's everything. We've got 0.148. That cues us in. We've got 0.14. Actually, that would be 149 if I round appropriately. Convert to a percentage. R is 14.9%. Yes, I will be picky about units. Make certain we convert the decimal to the percentage. Percent per 100. Move the decimal 2 places over. There we go. We've solved for R. We would need an interest rate of nearly 15% to raise that amount of money in 15 months. Solve for R. Next up, last thing we can do with the formula is we've solved for F, we've solved for P, we've solved for R, solve for the time. $1,600 deposited into an account earning 6% interest. So we've got our principal is $1,600. Interest, we are 0.06. Compounded monthly, N is 12. To the nearest month, how long will it take for the account to be worth $2,500? So we've got a final amount of $2,500. Plugging everything into the formula, we have f equals p, 1 plus r over n raised to the nt. We know everything except for t. Now remember, time is in years. So plugging in, we've got 2,500 equals 1,600. 1 plus 0.06 over 12 raised to the 12t. Variables in the exponent, that cues us in. We need a logarithm. But we'll work through everything outside first. Get rid of that. We've got 2,500 over 1,600 equals 1 plus 0.06 over 12. Now you could plug that into the calculator, get a value, but don't round it too much. Keep an extra few decimal points so we are not over rounding things. Raised to the 12t. At this point, the outermost piece is that exponent. We're going to log both sides. So we've got log of 2,500 over 1,600 equals the variable. The whole exponent comes out in a multiplication. 12t log 1 plus 0.06 over 12. Now once again, I'm going to save everything to the very end, plug it in the calculator all at once. This becomes multiplication, 12 multiplied by t multiplied by log 1 plus 0.06 over 12. Well, to cancel multiplication, we are going to divide. So I will divide both sides by 12. I will divide both sides by log 1 plus 0.06 over 12. That will leave me with t. Doing so, we're going to have t equals this side, log 2,500 over 1,600 divided by, be careful with your parentheses, 12 times log 1 plus 0.06 over 12. Now you could plug in each individual part in the calculator. Be careful with the division. I'm saving it all at once. That way I am not rounding anything. I'm only going to round at the very end. At this point, we'll substitute into the calculator. We have log 2,500 divided by 1,600, close parentheses, divided by open parentheses, the whole statement. 12 log 1 plus 0.06 over 12, close parentheses, all in at once. Cues me in 7.46. 7.46. Now the units are in years. I'm going to go back to the nearest month. How long will it take? Well, we've got 7.46 years. That's 0.46 of a year. Well, there are 12 months in a year. Multiplied by 12. Got 5.5 months. That would round up to 6 months. So 7 years, 6 months. We found how much time it takes for an amount of money to increase to a final amount. So, with our compound interest all the way through, we've solved for f and p last Friday. Now we've solved for r. Now we've solved for t. That's all we've got with compound interest. Try out the practice.